Okay, so today we're talking about the Pythagorean Theorem. Okay, that comes from a man named Pythagoras. We watched a few videos in class. They're on the website if you'd like to see them. In order to use the Pythagorean Theorem, you have to have a right triangle. In that right triangle, there has to be at least one, try that again, there has to be one angle of 90 degrees. Two sides of the right triangle called legs. So if I look at this, these right here are called the legs. And then the side that is across from the right angle, oh, I should use a different color. We'll use green. This right here would be the hypotenuse. Okay, so that would be the hypotenuse. We have two legs. They make up the right angle, and then we have the hypotenuse. Now, in some of the videos that you saw, you would have seen that this side right here, this leg, I should do a different color. The area of that square plus the area of, ooh, that was horrible, that square equals the area of the square of the hypotenuse. So what does that mean? That means that this leg squared, because that's the area of that square, this leg squared is going to equal the hypotenuse squared. Now, in this example, I did use L in both instances, but normally when we do this, we use an A, a B. Oops, sorry guys. I even said B and I wrote A, didn't I? How about that? And then last but certainly not least, a C squared. Okay, we're going to turn over our note packet. We're not going to do all of them, but I'm going to go here. Actually, we're going to come down here to this one. So I have a squared plus b squared plus c squared. That means the area of this that makes up this leg, the area of this this square that makes up that leg, and then the area of the square here. So we get a squared plus b squared equals c squared, and that's the Pythagorean theorem. C squared is always what the hypotenuse is. So we're going to go A, B, C. And I want to know what the area of this is. So I notice, hopefully on your piece of paper, you can see that those squares are there. So that it says, what's the length of AC? So this length right here is 3. And what's the length of BC? That is also 3. Down here, it says the area of the two smaller squares is 9, because 3 times 3, or I have 9 boxes in between, inside of this square. The area of the larger square is, well, we don't know that yet. But didn't it say a minute ago that we can do a squared plus b squared equals c squared? 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. So that gets 18 is equal to c squared. What is the length of AB? Well, right now it says 18 is equal to c squared, but that's not what I want. I actually want it to be c. Well, how am I going to get c? Remember when we did areas before and we were talking about squares? The area of this is 9. The length is 3, because isn't 3 times itself going to be 9? Well, right here, we don't have anything that the square root of itself, or sorry, a number times itself is going to be 18. So we have to come down here, and we actually have to take the square root. So we're going to take the square root of both sides of the equal sign. So that means C is going to approximately be, we're going to get a calculator to be able to do this. And we're going to get 18 square root of, and we're going to get 4.2. Now some of you are probably wondering, how did she do that? How on earth did she get 4.2? And this really should be units. Well, I'm going to teach you. Right here on my calculator, if I have a basic calculator, then I say 18 and I press the square root button, and that gets me 4.2. If I have a scientific calculator, it has to be a little bit different. If you notice on this, right here is where my square root button is. But if you notice, it's the little one above the x squared. So I actually have to hit, first of all, on, second, and then that square root button. And I get this. Then I plug in the 18, and voila, it gives me the exact same number. So I'm just going to use the simple calculator for these next ones down here. So it says the square root of 5. So I take 5 and I hit the square root button and I get 2.2. 12 and I hit the square root button, 3.5. 22 square root button, 4.7. 154 square root button, 12.4. And last but not least, 41 square root button, 6.4. So now you should be able to use a calculator to find the square roots. Next page. We're almost finished, I swear. It's using the Pythagorean Theorem. So let's move it just a tad. This time it gives you the A and B and you want to find the C value. It's nice and they already set it up for you. The A squared plus the B squared equals C squared. So 25 plus 64 equals C squared. 25 plus 64, that's going to get me 89 is equal to C squared. But I don't want C squared. I want C. So I'm going to take my calculator and 89 and I hit my square root button and I get 9.4. So that's approximately 9.4 units. This next one, it doesn't actually have anything written for our A and B, but remember A and B are the legs. So these are the two legs. So I have a 10 and I have a 5. Does it matter if I put 5 in the A spot and 10 in the B spot? No. So 10 squared plus 5 squared equals C squared. So I get 100 plus 25 equals C squared. 125 equals C squared. Sorry. 125 and my square root button, I get 11.2 units. Is approximately C. This next one says the legs are 6 and 7, and I want to find the hypotenuse. 6 squared plus 7 squared equals C squared. 36 plus 49 equals C squared. 36 plus, 36 plus 49 gets me 85. Take the square root of that. Now, do you notice right here it says round to the nearest 100th? If I have this, this is the tenths, this is the hundredth, so I have to look next door. That number is bigger than 5, so it's 9.22 units, approximately. Last page, guys, last page. Here we go. This time, I'm missing the B value, not the C value. So, I do the same thing. 25 plus B squared equals 81. You guys know how to solve that. We just subtract the 25 from both sides. I get B squared equals 56. So B is approximately 7.5 units. Almost there, almost there. Then, remember the leg and the leg. 20 and nothing. We don't know what that one is. Gets our hypotenuse, which is 22. So 20 squared plus B squared equals 22 squared. Now, could I have put the 20 in the B spot and have A looking for it? Yes. Doesn't matter. 400 plus B squared equals 484. Subtract 400 from both sides and get B squared equals 84. So B is approximately 9.2 units. Now the last of this kind, here we go. It says the right triangle has a leg of 12 and it has a hypotenuse of 23.4. I'm going to do A just to help you understand that you can switch it around. A squared plus 12 squared equals 23.4 squared. So A squared plus 144 equals 547.56. I subtract 144 on both sides. I get A squared equals 403.56, and then I take the square root. So A is approximately, rounding to the hundredth, 20.09 units. Now there is one thing that is not on here, is that you can only have certain numbers that can make it into a right triangle. So let's look at this. If I have, or I should say, they come out to be rational numbers. So if I had 3, 4, and 5 and said, is this a Pythagorean triple? Does it work to make a right triangle? Then you would put it into 3 squared plus 4 squared. Does that equal 5 squared? 9 plus 16, does that equal 25? Yes, 25 does equal 25, so yes, this is a right triangle. Give you another number. Let's say 3, 7, and 12. 3 squared plus 7 squared equals 12 squared. Remember, the biggest number is the C value. 9 plus 49 equals 144. Sorry, I forgot to put my question marks. So 9 plus 49 is going to get me 58. Does that equal 144? It sure does not. So no, that is not a right triangle. I'll do one more. Let's see. I'll do a different color. 5, 12, and 13. Do you think it's going to work? I don't know. Let's see. 5 squared plus 12 squared equals 13 squared. It's going to be 25 plus 144. I forgot my little question mark. 25 plus 144. Look at that. It works. Hello. Yes, that makes a right triangle. I hope these notes help.